This video is for the back of our Unit 2A test review. We're first going to start out with distributing and factoring, and we're going to start with problem A. Here we've drawn rectangles for you to use. You may choose to use them for the other problems, or you may choose not to. So I have 3 on the outside, and I know that that was pulled out of our parentheses on the left. So now I'm going to look what is in the parentheses to write it on the top. I have an x, and I have a -4. -4, -4, same thing. So now I have to find the area of each of these rectangles. Well, area equals length times width, so 3 times x is 3x. And now 3 times -4 for this rectangle, positive times a negative is a negative, 3 times 4 is 12. This means that up here, I'm going to write that 3 times x minus 4 is the same thing as 3x minus 12. Problem B. Again, if you would like to, you can draw the rectangles, or you can just use the arrows of distributive property. 2 times 3y gives me 6y. 2 times a -8, think about your Illuminati, positive times a negative leaves us with a negative, so this is going to be a -16. Okay, problem C. I'm doing 0.2, which is 2/10 times m, which gives me 2/10 m. And then I'm doing 0.2 2/10 times 9. Well, let's do this math really quickly. 9 times 0.2. 2 times 9 is 18. 0 times 9 is 0, so we don't have to think about it. We don't have to worry about it. I have 1 decimal place behind my decimal, so that means my answer, I need 1 decimal place behind my decimal. And so our answer is a positive, because it was a positive times a positive, 1.8. Problem D. Now we're switching to factoring. Factoring is the exact opposite of distributing. Notice with distributing, we started with what was on the sides, on the left side and on the top. And now with factoring, we're starting with what's on the inside, our area. So I brought my 4x and my -32 down. Well, looking at 4x and 32, both of those numbers are divisible by 4. So I can divide out a 4. 4 times what gives me 4x? Well, 4 times x. 4 times what gives me -32? Let's think about it. I'm starting with a positive and I'm ending with a negative. So that means the other number must be a negative number. So 4 times a -8 equals 32. To write this, since the 4 is by itself on the left, the 4 is by itself outside of our parentheses, and then I have x and a -8 in parentheses. Let's look at E. With E, I have 10y, and so I'm going to put that on the left side, and I have -25 on the right side. Well, I can pull a 10 out of 10y, but I can't evenly pull a 10 out of 25. So I'm going to have to think, what is the biggest factor that goes into both of them? Well, both 10 and 25 can be divided by 5. So 5 is the biggest number that I can pull out. 10 divided by 5 is 2. And I would need 5 times what to give me 10y? Well, 5 times 2y. 5 times what is going to give me a -25? Well, I know that a positive times a negative equals a negative, and 5 times 5 is 25. So here I pulled out a 5 on the left-hand side. I was able to divide out a 5, and I was left with 2y minus 5 on the top. Finally, problem F. I have -12x and -16. Okay, again, I have to think about what number can I divide both 12 and 16 evenly by. Well, let's think. Our common factors, they can both be divided by 2, but let's see if there's anything bigger. Think about it. Well, I know 3 times 4 is 12. And 4 times 4 is 16, so I can pull out a 4 out of both of those. Even better, look that we have both negative numbers, so I can pull out a -4 out of both -12 and -16. Now I have to think, negative 4 times what is going to give me a negative 12x? Well, negative times a positive gives me a negative, so it's going to be a positive 3x. Negative times a what gives me a negative times a positive, so this is negative 4 times positive 4 is going to give me a negative 16. I pulled out the negative 4, I divided that out, that was their common factor, and I'm left with 3x and a positive, so plus 4. All right, let's go on to the next one. This one's asking us for a justification. So it says, Gabby believes that, whoops, typo here, it should say she, that she can use the properties to rewrite 14 divided by 7 as 7 divided by 14. Identify which arithmetic property Gabby is trying to use and explain if her reasoning is correct. So if it helps you, you can look back at your properties on the first page at this point. And I'm going to think, well, look, she's doing 14, 7, and she's thinking that's going to be equal to the same as 7 divided by 14. So I'm going to write that out. 14 divided by 7 is the same as 7 divided by 14. Well, let's think about that. Notice she changed the order of the numbers without changing anything else. So the property that she's trying to use is the commutative property of multiplication, but she's trying to use it for division. Let's see if this works. 14 divided by 7, well, that's 2. But 7 divided by 14, I could rewrite that as a fraction. 7 divided by 14. And I can reduce that fraction. Both those numbers can be reduced, divided by 7. That gives me 7 divided by 7 is 1. This is our giant 1. And 14 divided by 7 is 2. So we have 14 divided by 7 is 2, but 7 divided by 14 is 1/2. These are not equal. Remember that the commutative property stated that we have to be able to change the order without changing the answer. This does change the answer, so her reasoning is incorrect. So we can say Gabby is trying to use the commutative property for division, but it only works for, and if you look back at your notes, we wrote down that the commutative property only works for addition and multiplication. Okay. All right, let's now look at our section on combining like terms. All right, I'm going to start with my squared terms. So I have 6p squared plus 3p squared, and that's it. Well, these are both positive, so 6p squared plus 3p squared gives me 9p squared. All right, now that I've dealt with my p squareds, now I'm going to look at the p's, the terms that just have a p. So this is what I'm going to do next, what we would normally call our x's. So I have 5p plus 18p. Well, again, both of these are positive, so I can just add them together, and that gives me 23p. Finally, all I'm left with for my units is a positive 17, so there's nothing else I can combine it with, and this is our most simplified answer. Problem B. Okay, I'm going to deal with my x squareds first. So I have negative 3x squared, and I have negative 11x squared. Well, we can still do our positive and negative teams, and I have negative 3 and negative 11. Since these numbers are on the same team, that means that we can just add them together. There's 14 on that team. Well, we're on the negative team, so that gives us a negative 14. So that means I have negative 14x squared. Now that I'm done with my x squareds, I can concentrate on my x's. I have 15x and I have negative 22x. Again, I can think about my positive negative teams. I don't have a lot of room over here, but I'm going to write it really small right over down here. I have 15 on my positive team and I have 22 on my negative team. Since they're on opposite teams, that means I have to subtract. 22 minus 15 is 7, and since the negative team is winning, it has more teammates, that means I have a negative 7. Remember again that we're dealing with x's, so that's a negative 7x. Finally, I have a positive 48 for my units, and I have a positive 14 for my units. 48 plus 14, 8 plus 4 is 12. 1 plus 4 is 5, plus 1 more is 6. So plus 62 units. Problem C. Again, I'm going to start with my squared term. So I have 22m squared plus 1 more m squared. Remember that there's a hidden 1 here. There's just 1 more m squared. So 22 plus 1 is 23m squared. Next, I'm going to look at my m's. I have negative 4m and I have negative 13m. Again, we can think about our positive and negative teams. Well, I have negative 4 and negative 13. Since they're on the same team, that means I can just add them together. That means we have 17 on our negative team. So that means I have negative 17m. Finally, I have a positive 18 and I have a negative 17. Again, I can think about my positive and my negative teams. I have positive 18, I have negative 17, or you could just think of this like a simple subtraction problem. 18 minus 17 is 1, and we're on the positive team is winning, so we have a positive 1. All right. Finally, problem D. This one, remember, is worth double points because you have to distribute and then combine like terms. Since I always do multiplication before I do addition, order of operations, Gemma, M comes before A. That means I have to distribute the 6 first, and I can just ignore this negative 4 right now. Negative 6 times negative 4x, positive times a negative, Illuminati, gives me negative 24x. Positive 6 times a positive 3 gives me positive 18. And now I can bring down my negative 4 plus. Okay, I look at my x's first. There's nothing else I can combine with that, so that's going to stay as a negative 24x. Then I have negative 4 and positive 18. Well, let's think of our positive negative teams. I have negative 4 and positive 18. They're on opposite teams, so I need to subtract. 18 minus 4 is 14, and positive wins, so I have a positive 14. This is as simplified as your answer can get. All right, finally back to Unit 1 stuff. We are going to do our spiral review here. I have negatives and more negatives, so this means that I can add 1.6. And remember, with addition, you need to line up your decimals, plus 5.02. Well, I can add in a 0 here. 0 plus 2 is 2. 6 plus 0 is 6. Then I bring down my decimal, and then 1 plus 5 is 6. Since I have negatives and more negatives, that means I have negative 6.62. This would be like going left and then further left on your number line. 2 plus negative 1 3/4. I have a positive 2, which I could think of as, if I want to change it into fourths so that I have a common denominator, well, that would mean that 8 goes into 4 2 times, plus I'm going to change my mixed number into a improper fraction. 4 times 1 is 4, and 4 plus 3 is 7. So I have 7/4, and then remember that we have this negative here, so minus 7/4. If I have 8 plus a negative 7 on the top, this is the same thing as 8 minus 7. Adding sand or taking away gas is the same. 8 plus a negative 7 is 1. And we keep our common denominator, so this is 1/4. Okay, here we are taking away sand, which remember we said is the same as adding gas because either way you go up. So these are now becoming opposites. When we have opposite signs, you always have to subtract. So I have to do 4.8 because that's our larger number, minus 0. Notice I'm lining up my decimals, 0.01. Okay, I can't do anything yet, so I have to put in a 0 there. Since I have 0 minus 1, I can't do that, so I have to borrow. This becomes a 7, this becomes a 10. 10 minus 1 is 9. 7 minus 0 is 7. Bring down the decimal, 4 minus 0 is 4. Okay, I had more positives than negatives, so this remains positive. Our answer is 4.79. Okay, next one. 2 1/4. 4 times 2 is 8, plus 1 is 9. I'm changing my mixed number to an improper fraction, 9/4. Plus 3 times 1 is 3, plus 1 is 4. I have 4/3. This is a negative. What's important here is to add, you have to have a common denominator. I do not. So I'm going to have to think, what do 4 and 3 both go into? Well, I can change these both into 12ths plus a negative 12. Okay? To change fourths into 12ths, I have to multiply both of these by 3. 9 times 3 is 27. To change thirds into 12ths, I have to multiply this by 4. Whatever you do to the bottom, you have to do to the top as well. 4 times 4 is 16. Notice I brought down the negative. 24 plus a negative 16, well, I have opposite signs, so we subtract. This becomes 27 minus 16, which is 11. And then our denominator stays the same since it's common. Our answer is 11/12. E. Notice now we're doing multiplication. With multiplication, you do not need a common denominator. I still have to change this into an improper fraction. So 3 times 4 is 12, plus 2 more is 14. This is 14 over 3. Our denominator does not change, and I'm bringing down my negative sign. Times 6 over 7. At this point, you can either multiply and then simplify at the end, or make your life a lot easier by cross-canceling. Well, I'm looking at the numbers that are across, 7 and 14. Those can both be divided by 7. 7 can be divided by 7 one time. 14 can be divided by 7 2 times. Now I'm going to look at 3 and 6. Well, both 3 and 6 can be divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Now I'm just going to multiply across the top and the bottom. I have a negative 2 times 2. Negative times a positive is a negative, Illuminati. And 2 times 2 is 4. Then I have 1 times 1 is 1. Negative 4 over 1 is the same thing as negative 4. Negative 4 divided by 1 is equal to negative 4. Finally, our last problem. Again, to change a whole number into a fraction, you can just put it over 1 because 3 divided by 1 is still equal to 3. Remember that to do our division problems, we've used keep, change, flip. So I'm going to change this to a multiplication symbol, and I'm going to flip this. I'm going to find the reciprocal of 9/14, which is 14/9. Again, I'm going to look. Can I cross cancel? And yes, I can, because both 3 and 9 can be divided by 3. 3 goes into 3 one time. 9 divided by 3 is 3. 14 and 1, well, 1 goes into everything. Dividing by 1 is not going to help us. So let's look what I have. 1 times 14 is 14. 1 times 3 is 3. I'm not quite done yet because this is still an improper fraction. So now I have to do my division. I have 14 being divided by 3. 3 goes into 14 4 times. 4 and 3 times 4 is 12. So I can take away 12 and I'm left with 2. That means I have 2 left over out of my denominator 3. So this is equal to 4 2/3. I hope this was helpful and good luck on your test.